Give me a second, everybody. Just checking that my cat's okay. Okay, we're good. Both my cats are okay. Sorry for the delay. Okay, so like just quick introduction. If you haven't been on this stream before, you're coming in later. We've been working on like a rail shooter lately, like sort of just like a new mode. That's like a fun little diversion from most of the work I do all week. I can show you that real quick. Zoop. Yeah, don't mind this like checkerboard pattern background. It's just a placeholder for like a desert planet or something. But, oh my, that was really loud, wasn't it? So yeah, we got all these enemies out here. So like the first thing we did was we built like the structure of like there's a spline that you attach to and it can have branches and joining paths, and I did these sort of like visualizations of its extent. So like when you're on the right hand side of the spline, the character's on the right hand side of the screen, and when you're on the left hand side of the spline, whoop, the character moves to the left hand side of the screen. And then we added these enemies that spawn behind you and then run in front of you. And we gave them like little wasp bodies and little wing flappy animations, and we have them like spitting sort of green goop at you. And so now, like, I think what I want to work on today is like right now, like horizontally, like in the screen, they just kind of like go in front of you at like a fixed position, and that's just where they are. So if I fly over here, they're not like actually trying to like track me or shoot at me. They're just staying at the same place relative to the spline. And I want to have them actually like move around and track you. So like if I go to the right, they go to the right. If I go to the left, they go to the left. And also like because they're aware of like the squad and their group, like maybe they make patterns. Like maybe they make a cross-shaped pattern, or they make a circular shaped pattern or something. So that's the main thing we're going to do today. But in the meantime, this is just sort of a peek behind the curtain of game development. I've got some like kind of like key art that I need to put together, like an update on some older key art that we made for Comic-Con in preparation for some promotion that we're going to be doing. So I just need to finish up making an update to an old image that we had. Here I can show you. This was how it looked before. See, we got Kit, and we've got her like robot fighter, and we've got like a big scary like robot spider in the background. And we just want to update this because we've got like a new, nicer looking like version of the like robot model. So I'm just updating that right now, and I'm also making the composition like a little bit better. So you can just enjoy watching me fiddle with a camera and a character for a little bit, figuring this image out. And then, yeah, after maybe about 10 or 15 minutes of that, we'll go back to programming the enemy AIs. So, yeah, that's what we'll do. As always, the chat is basically just like an ongoing AMA thread. So if you want to ask me anything, like I'll read it out and answer it for you. It doesn't have to be what I'm working on. It can be anything. If you're just on like Twitter or wherever, or Instagram, and you saw something cool about the game and you want to know more, just ask me any questions. I'll let you know. Cool. Thanks for watching. think we're so close. Let's gotta get this robot in the right place. Okay, enough of the image fiddling. That's quite a half hour of thrilling excitement watching me adjust stuff by a centimeter at a time. Huh? Anyway, let's get back to the game. So, here, let me bring up the code. Boop, boop, boop. Let's make the font a little more legible. There we go. Okay, so enemy jet spline from behind was the weird name and code that I picked for these wasps that appear behind you on the spline and then fly in front of you. So just to go through, I've got this like state machine here. They spawn. Once they have a squad, they enter their approaching state. In their approaching state, they basically just adjust themselves to get in front of you. Once they're in front of you, they enter this out front state. And then out front is handling when they're in front of you. So now I think what I'm gonna do is, because you can see all of them have this like anchor offset position. And this is like, if you think about like the spline, there's like a, here I got my handy dandy thing here. So like the spline, you find the closest point on the spline, that gives you like an anchor. Okay, so you can see in Unreal the X is forward and the Z is up. So like we're going to be at a position that's relative to this. So our X coordinate here is 0 because we're just aligned with this plane. And then the XY position is like my horizontal and vertical offsets from the spline. And right now I just calculate it once when you enter the out front state. And then I never change it. That's your offset from the anchor forever. So instead what we want to, yeah, like basically that's used, where is it? Yeah, here we are. Your target position is, you get your target anchor and then you take an offset from that. So instead what we want to do is we want to think about like, there's going to, let's just have, okay, this is going to look dumb, but like, let's just like, let's say we can get the pawns anchor offset from the spline, and let's have everybody just sort of like try and go towards the spawn. So, or go towards the players like horizontal and vertical offset from the spline. So player goes to the left, everyone goes to the left. Player goes up, everybody goes up. It's going to look silly, like they're all going to be clustered together and they're all going to be kind of like glitching out because they're all going to try to go the same place, but their collision is pushing them apart. So this isn't going to be like the right answer, but like I just want to like start somewhere, right? So somewhere is they're all just trying to go towards you. And I think level 2 will be based on how many people are in the current squad. They'll like try and do like a ring around your position where like the person 0 in the squad is like directly above you and person 1 is to your right, and person 2 is below you, and person 3 is to your left, and they'll form like a diamond if there's 4 of them, something like that. Oh, hey little guy. Looks like my son has returned. Come on up. Come on. Yeah, that's right. What's up, pal? Yeah, so this class I'm editing right now, Arena Spline, this is the actual spline that you place in the world. So basically, whenever the player is like attached to the Arena Spline, it records a bunch of information about the player, like what's your progress along the spline, what's your relative offset to the spline, what's your relative direction, are you going forward and backwards, stuff like that. This way we don't have to recompute it for every single enemy. The player can write it once to the spline, and then the squad can read it back from that spline. Since like they usually like to think in terms of like where are you relative to the spline as opposed to like what's your like absolute XYZ position in the world. So I just replaced this. This was a vector parameter, now I'm calling it a damped vector. This is just a helper class that I made to track basically values that you're passing through a low pass filter. So like, you know, you're blurring it essentially. So instead of everybody like snapping to the player's position, they're going to kind of smoothly interpolate towards the player's position. What? Super needy boy. Don't mind my cat, he's just licking his butthole. He was sensitive enough to point it away from the camera today. Tact. I'm getting ready with my camera. Sometimes when he does this, he makes a really funny face, and I want to get a photo of it. What's up, buddy? So I updated it so that the enemies should constantly be trying to adjust their offset to match the player's offset with a low pass filter. So they're all going to kind of try and follow me, but they're all going to crash into each other. Actually, just for starters, let's just reduce the squad size to 1. So we don't have to think about them interfering with each other. So I'm going, one guy comes out, now you can see He's like tracking me around. I wonder why he's not like super perfect. Like, I guess even when he's matching me, he's not, like, his bullet's going below me. I guess that makes sense, because in that animation, like, their tail is below, and it's being spawned from that joint. I wonder if we should update that animation so that the tail is, like, or... No, let's just like, we just want to push him up a little bit, right, to account for the fact that he's shooting below. So we'll just add a property here. Property, so I have to save and restart. Okay. Due to like differences in the spline between their position and my position, it's not perfect, but it's basically hitting me on straightaways. We could like improve their aiming. We could make it like kind of aim towards me and not just shoot directly in the direction it's facing. But this is at least like a pretty good start, right? Like now, you know, I go over here and it tries to like follow me. It hits me. I come over this way. It gets me over there. Cool. So now, like I was saying, if I like increase the squad size, they're all gonna clump on top of each other because they're all gonna try and go to the same place. I can come in here. I should make this billboard a little bit bigger so it's easier to find. That property does, but it's clearly not a size. Does scale work? Yeah, scale works. We'll just scale it up. Okay, so if I make the squad size now, let's say 4, that means it can spawn 4 at a time, and so they're all going to clump up on each other. Yeah, there they are. They're like a annoying little cluster. And you can see they're kind of vibrating because of the collision. So now what I want to do is, for each one of them, we're going to know like what your index is. So like we know there's 4 and we know there's their index is going to be like 1, 2, 3, 4, or it's computers, so we usually start counting in zeros. So 0, 1, 2, 3. And then based on that, we'll pick, yeah, like I said, like a ring with a certain radius, like around the player. Let's try that. So that's pretty cool. Like, they form a little circle. Every time one explodes, they make room for a new one. So yeah, we can come in here. We can increase the spawn count. Maybe make it 12. And now, like, because it's just a circle, they should still just form a ring where they're still like evenly spaced. So let's see if that's working. Okay, it's kind of working, but they just don't have enough room. I think, yeah, like if we made the ring 3 times larger. Man, I'm gonna turn the audio down. That's really annoying. But I think one interesting thing is I like blow one up, and then instead of the new one just taking that one spot, like another one goes into it, right? Just because it's just based on their like index in this array, and that index isn't really based on anything. So I think what we need, I'm trying to think, it's like we can always resort their indices when it spawns in. What is this? Irish John Games is raiding with a party of 48. I guess a lot of people are showing up. But here, 48 sounds like an interesting squad number. Let's type that into the spawn count and see what happens. It's gonna be wild. Let's see, not sure you know, but you have follower only chat on. I don't know about that. Sorry, I'm like very new to the whole how Discord chat, not Discord, how Twitch chat works. But they said you can type followers off unless you want it on. You know what? Let's type followers off and see what happens. Cool. So yeah, just to sort of like fill in everybody who just came in, this is a Devstream. I'm working on this like robot shooter arcade game. Transform into a jet. Look at that. I'm working on like Star Fox style spline sections right now. And in particular, I'm working on this wasp spawner. So I get into the spline section and then it spawns a bunch of wasps. So you can see what I had in a control here was I can do a squad size of 8. You can go down to a squad size of 4. Oh, there's so many pirate talk happening. Here's a squad size of 4. Every time you blow them up, a new one comes out. And so what I was thinking about was just this sort of weird thing where they kind of like exchange places sometimes when new ones spawn. And that one looks kind of weird sometimes. So I was gonna like do a little bit of investigation on what we can do about that. So get ready, we're gonna look at a whole bunch of C++, because this is what enemy AI looks like. Beefy Your Egg said, did you know C# is actually C+++++? Yeah, that was a little joke they made at Microsoft back in like 2001. Yeah, so what I'm doing here, by the way, is this is where the squad spawns a new member. And all I'm going to do is sort all the instances based on the angle they make with the spline. And then I'm going to reassign the squad index parameter based on their new position in the array. And that'll just like make sure that like the squad formation doesn't go crazy every time a new member is added or removed. It'll just like make space for it or close the gap. If this syntax looks weird, if you're like new to C++ or whatever, instance is an array. This is like Unreal's special array type. Sort is a function which sorts the array, and it does it by taking this predicate function. Unreal or C++ now lets you write functions inline. So this predicate function takes a left-hand side and a right-hand side. It's basically saying, should this come before this, true or false? So you write this predicate function, and then it has a bunch of like goop, like internally. If we go in here, oh yeah, it's like pretty deep, but like it's doing this sort of like quick sort thing, where it just sort of minimizes the number of comparisons it needs to make to figure out how to totally sort the array. And then this first parameter here is basically anything from the surrounding environment that we want to capture. So we're just taking like the transform of the player. We're going to get everybody's position relative to that, and we're going to compute the angle from that. These ATAN functions here, that stands for arctangent. It's like high school trigonometry. Anytime you're dealing with angles, you have to do trig functions. By the way, I always use this word it in loop variables. That's just short for iterator, which is math speak for, where we are in a loop. So what this loop is doing is it's going through all the instances, and it's just reminding each instance where they are in the squad list. So let's rebuild the game and see if this works. Okay, looks like they're still doing something of a weird dance. Like sometimes the new one comes in on the left and then scoots over to the right. I'm wondering if that's like the angle, like an issue with the angle wrapping around. And sometimes guys that don't seem like they need to exchange position are exchanging position. Let me just do a quick review of the code we just wrote and make sure I don't spot any bugs just from a quick inspection. Maybe they want to be sorted in the reverse direction than what I was thinking. Let's see how that works. Yeah, that's strange. I can't quite put my finger on what's going on there. Let me think about this for a second. Here, let me right now it's basically like measuring the angle from pointing to the right. And then it's left-handed, so it's like this. Maybe I can like invert, like transpose the coordinates in 2D. By the way, I'm using Y and Z because X is your like depth. So this will measure it like starting with the vertical, like starting from like 12 o'clock. Very curious. Okay, well let's just back that all out. I don't think that works at all. And we will... Yeah, we've still got this old logic here, that's fine. We'll just leave it that way for now. But there is the issue where like, if I'm just flying into the screen and they're all making a ring around me and shooting straight, none of them are hitting me because they're all offset from me. So I think I'm gonna have everybody actually have a little bit of like aiming so that they can aim towards me so that I actually have to dodge. You know, this is actually like a little trickier than it seems because like if you think about it, like if you ever played Space Invaders, you don't want to shoot where things are, you want to shoot where things will be. So I'm going to have to like inspect the speed of the bullet that they're shooting. And I'm going to have to inspect how far away I am from the player. That'll tell me how long it should take the bullet to get there. And and then I'll look at the player's speed, and I'll just like extrapolate from the player's like current position with their current speed to get where I think they're going to be at the time that the bullet actually gets there. And then I'm going to aim at that position instead. So let's see here. Where did we actually... Okay, here's the try shoot event. It looks like I'm doing all the shooting in Unreal scripting language blueprint. So let's go back into that, and we'll just see where I'm spawning the bullet, and maybe internally in the bullet I can do all that logic. Yeah, here we go. When the game says, hey, you should shoot, they play a little animation, and then they spawn a projectile. The projectile has a speed, so we know what its speed is. And it just offsets... Where is this? Sweep enemy projectile. Oh yeah, this was a function I wrote. Here. Whoop. Window opened up on the wrong screen. So yeah, sweep enemy projectile. The projectile is just moving along the forward direction. So we just need to make sure to point it in the right direction when we spawn it. So there we go. We've spawned it here. Actually, let's write a little function. Spawn bullet. We'll take all of this code and we'll move it into spawn bullet. Now we can make local variables, which will make this all a lot cleaner. So here we say spawn bullet. So then inside of here, we have the location that we want to spawn from. So we'll make that a local variable. And then we can get the player position. So we can make this a local variable. So then we can get the distance between these two locations. And then we divide that distance by here. We actually need to spawn the bullet first. So we'll figure out the spawn location. We'll spawn the bullet at that location. Then we'll get the pawn location. We get the distance from the spawn location to the pawn location. And then we divide that by the speed of the bullet. This is going to get very unreadable. I'll rewrite this in C++ later. But so now we have distance, that's in like centimeters, and we have speed, which is in centimeters per second. So if you take centimeters divided by centimeters per second, it's going to be centimeters times seconds per centimeter. Centimeters cancel out, and you just get seconds. So this is the number of seconds it'll take the bullet to get from this spawn location to this pawn location. So then we want to take this time and we want to multiply it by the local fighter's velocity. Vector times float. So now this is how much we think the player is going to move in the time it takes the bullet to get to them, right? So we can add this to the pawn's location, and this is like where we think the pawn is going, like the player is going to be. Oh, what is this? I see you, April Dawn says maths and maths and maths. Ducks, I love maths. That doesn't mean it loves me back though. Aww. Maths is just like a game. If you like playing games, then you like doing math. It's like solving a puzzle every time. But so now we have where we think the pawn's going to be. We have where you spawned it from. So if we subtract where the player is going to be from where we're spawning from, this vector should now point in the direction of where we actually want the bullet to go. So now we'll say make rotation from X. We're saying from X because X is the forward direction in Unreal. And then we're going to set vector rotation. And that is going to be set to this rotation here. And we've written all of this gobbledygook. I hate it. But at least it's not here. Let's just move a bunch of this stuff over here. So at least the main logic of it stacks up. We mark where we're spawning from, we spawn the bullet, and then we rotate the bullet to face in the direction of where we think the player is going to be. So now everybody should be shooting like at the player, and I should just be getting like destroyed. Nope, I'm not. Look at all those bullets. Are they facing the wrong way? What's happening? Yeah, they're facing... Oh, they're all shooting them in the opposite direction. Wait, did I get these backwards? That can't be right. Let's see. Something very wrong is happening here. Unfortunately, all of my math here is incomprehensible. Here, let's clean this up a little bit. So we're gonna set the new bullet's rotation to so it should be the destination, which is like this, minus the spawn location. So I think this was right, but something else is clearly wrong. So the destination Just cleaning this up to make it more readable. So we got the distance from the spawn location to the pawn location, and the pawn location is definitely just the local fighter pawn's location. Local fighter pawn is the local player. And what we did is we took that distance, we divided it by the speed. Let's clean this up. So call this bullet speed. And way over here we can just say get bullet speed. So the distance divided by the speed should be the time. Then we can collapse this and we say, oops, not like that. Estimated time to player. You multiply the estimated time to the player by the velocity of the player. And then we add that to the player's location, and that is the estimated location of the player. So we can collapse that. Then we take the estimated position of the player minus the spawn location. That's the direction we want the bullet to face. We make a rotation for that. And we're doing like make rotation from X. And then we're setting the bullet's actor rotation. This is all right. What is happening here? Oh, I guess it does not like collapsing nodes like that. Yeah, I guess it doesn't like it when you put local variables inside of there. Can I just like right click fix this up? There we go. Okay, it's less pithy, but here we are. The player's velocity times the estimated time. Here, let's just get rid of this estimated time thing for now, maybe. And just say pawn location minus spawn location is the rotation. See if that isolates the bug. Nobody is shooting towards me. What's happening? Am I getting any like errors in the log here? No? Baffling. Just so many baffling things happening today. Welcome to game development. Here, I'm gonna put a big honkin' arrow on each bullet so that I know which direction it's going. Now we can see which direction they're facing. Where are these bullets going? Okay, so I guess like when this one was fired, it was looking at the player. So now if I hook this back up, let me make this arrow bigger. They're all pointed that way. Is it that like the speed on this guy is really slow? Okay, 500. So maybe it's like reckoning that like by the time it shoots, like I will have already passed its spawn location, and so it needs to spawn in the opposite direction? That seems weird. Let's just like have the amount of time that it's extrapolating. Let's see what happens. Actually, rather than having the time, let's just make the bullets really fast and see what that does. Okay, they're clearly like shooting towards me, but like not quite hitting me. I think maybe it's just because I'm so far away from them and they're moving so slowly that the time that it reckons it'll take to get to me is so long that like when it extrapolates my position that far, I've like super overshot them. So maybe we just use like a fixed time. We'll just extrapolate like half a second in the future. And I'll take the bullet speed back down to 5 meters per second. They're still really bad at hitting me, huh? I wonder... This is a radical notion. So they're firing like I'm moving forward and they're reversing. So they're like shooting behind themselves, right? Like what if we just deduct, oh, excuse me. What if we like deduct that initial speed that they have when they're being fired from their movement? So here we'll go to this sweep projectile method. I'll make a variant of it for now, just with initial speed. Doubling up my braces. So we'll modify this function by just copy pasting and then changing it. So now P1 is going to be my old location and P1 is going to be my old location plus the speed times the delta time plus the initial speed. So we'll start building this. Oh man, my cat is really out. He is like quivering. Oh hey buddy. Oh, did I wake you? Okay, we're a little over on time and I'm actually pretty busy today, but I do want to see how this works. So we'll finish this thought. BP wasp, was it called wasp projectile? Yeah. So now you have a new parameter, which is initial speed. It's a vector. And then internally, instead of sweep enemy projectile, we're going to say sweep enemy projectile with initial speed. Same projectile, same radius, same damage, same speed, same delta time, but now also initial speed. Now we go to BP wasp. Do the wasps know, do they expose what their current velocity is? Oh my goodness, what have I done? Oh, I accidentally put a breakpoint in. So, from behind, yeah, pose dot velocity. So let's expose that to the blueprint real quick. So then, in wasp, when we spawn the bullet, we can can say set initial speed to get vel, the method that I just wrote. Where are they going? Something very bad is happening. Oh, I wonder. For the function. Forgot to convert the speed to distance. Okay, so now it has their like initial momentum built into it. So what we want to do now is here. So here it's now we want to take the velocity minus the shooter's velocity. We only want the relative velocity. Oh, excuse me. And then, yeah, so here, yeah, here we're just multiplying by a fixed time. Oh, okay, they're better at hitting me. They're moving really slowly because they're shooting them really slowly while they're moving really quickly. So we actually want the wasp projectile to move a bit faster now because it needs to overcome the speed that it's being shot from. So maybe I'll triple it. I'll shoot them 3 times faster. Let's see how that looks. Zoop. Yeah, now they're starting to reliably hit me, even if they're not aligned. I'm dead. Okay, cool. We can take this arrow off of here. Now when they spawn, I need to actually... Whoa, they're a little too good at hitting me, maybe? This is like a little more fun. It looks a bit wild though. Not gonna lie. I wonder if it's extrapolating too much. Maybe only extrapolate 0.1 seconds. I think one thing I want to do is get the trail off of there. I think that's more confusing than helpful. So ribbon data, we'll turn the ribbon off. Where are these things going? They're all over the place. What if there's no dead reckoning now? It just points it at me, but it accounts for the initial speed of the shooter. Okay, they're hitting me, but it looks really weird. Also, I'm curious why sometimes it shoots in the opposite direction. Okay, so it's technically correct. If I'm like holding steady, they do aim at me and the bullets do hit me. Barring some like inaccuracy because they're not that good. Because they're kind of assuming that I'm moving at like the same constant speed as them. But like, even though they're offset, they are hitting me. So it's like pretty accurate. It just looks weird. It's like not great gameplay. I think like maybe things that get spawned, like for this to like read correctly, I think it just needs to have like a velocity of 0. Yeah, what if the speed here was just nothing? And it didn't use that initial speed. It was just sitting in place. Yeah, so here the bullets are like stationary, but they don't look stationary because I'm flying forward. This is a more like arcadey kind of thing. It's like more legible. I guess it's only threatening if they like get directly in your way, and if yeah, let me change that. Like I'm only 5 meters away from directly in front of you. Yeah, this is like actually pretty fun, because they're basically, it's not like they're shooting directly at you and trying to hit you, it's just that they're creating zones of exclusion. Wait, so if I get them basically, if I get 8 of them, I think they're all going to be on top of each other. I need to make this a little bit bigger. So yeah, they're a little bigger ring. There's 8 of them. And they're kind of like, yeah, like I can go over here, but it's like I have to be just a little bit more careful about what I'm doing. And then if I configure the timing of the shots here, minimum time to shoot shots, 0.1 second. Let's say 0.05 seconds. Let's say they shoot twice as fast. Oh, they also have their own cooldown between shots. So we can reduce shot cooldown to half a second. Now they should be shooting basically continuously when there's 8 of them. Yeah, they're technically shooting in a ring, it's just hard to see. I think I need to like think on this, I need to do a little bit more experiment, but this has all been like good stuff to chew on. So anyway, we have passed 420. We have neglected to blaze it. But yeah, this was fun. It was fun for the first half, setting up the poster, and it was fun the second half, just finding various math bugs and weird things and having to think about how like I'm usually thinking about a turret as being a stationary thing trying to shoot you while you're flying around, but this like both of us are in motion and we're both like in sync and we're actually moving relatively quickly. It's given me a lot to think about. I like wonder if like it would be better to like slow down how fast we're moving in the tunnel, or if it would be better to like speed it up and just make all the bullets stationary so that they're just coming at you faster. There's like a lot of like interesting, a bunch of interesting stuff I hadn't thought about. I'm probably gonna like go back, and I've been replaying like Star Fox Zero and Panzer Dragoon lately to see how they handle this kind of stuff, so maybe there's some inspiration I can draw from that. But anyway, I got a bolt. Thank you everybody for watching. Thanks all the pirates who showed up and told me how to unlock the chat. I'm slowly going from noob to slightly less noob when it comes to Twitch. And yeah, we do this every Friday, 2 o'clock Pacific time. And it goes up on VOD. We have a whole archive on YouTube. So this was like Railshooter Part 5. You can watch Part 1 through 4 and how we got this far. And yeah, cool. Thanks for watching. Bye. Wait, is the boy gonna say bye? No, he's just sleeping. Okay, bye.